Hi everyone. You will learn some gas laws. The first law is Boyle's law. In the Boyle's law, we will see volume-pressure relationship. Boyle observed that as pressure increased, volume of air decreased at constant temperature. As volume increases, pressure decreases. As volume decreases, pressure increases. Thus, Boyle's law is stated: as long as temperature and amount of gas are kept constant, volume of gas inversely proportional to pressure applied to it. We can say temperature and amount of gas should be constant. Volume and pressure, and we can say V inversely proportional with the P, V 1 over P, and V is equal to constant time 1 over P. From here we can get the relationship between P and V. P1 V1 is equal to P2 V2. Example: the pressure of perfume in half a liter bottle in 3 atmosphere. If applied pressure were 6 atmosphere, what? From V1, P1 is equal to V2, P2. V1 is given, P1 is given, P2 is given, and V2 is unknown. V1 is 0.5 liter, P1 is 3, V2 is unknown, and P2 is 6, and V2 is equal to 0.5 times 3 over 6, and V2 is equal to 0.25 liter. Exercise 2.4. If the pressure of 50 liters of gas in a balloon was reduced from 1 atmosphere to 0.9 atmosphere, what will be the final volume of the gas? V1 is given, P1 is given, P2 is given, and V2 is unknown. We can write the relationship again. V1 times P1 is equal to V2 times P2. V1 is 50 liter times P1 is 1 ATM is equal to V2 times P2 0.9 ATM, and V2 is equal to 50 liter times 1 ATM over 0.9 ATM. ATMs are simplify each other. 50 over 0.9, it's equal to 55.5 liter. Another law, Charles law. In the Charles law, we will see temperature and volume relationship. When temperature of all gases increase, also their volumes increase. According to the Charles law, temperature in Kelvin and volume of gases change in direct proportion when mass and pressure are constant. We can talk about the relationship between V and T here. V and T directly proportional, and that's why V over T is equal to constant. V over T constant. From here we can make some relationships, V1 over V2 is equal to T1 over T2, because in the same gas, in the same amount and same pressure of gas, we can make this relationship V1 over V2 is equal to T1 over T2, or V1 over T1 is equal to V2 over T2.
So what we're going to try to do is blow up this balloon inside that bottle. And normally if you think about it, it's pretty hard to do. You blow into it, and as soon as you fill it up, and if you take your mouth out, the air will come out, and it's because there's a higher pressure inside the balloon, so it's very hard to do. But what we're going to do here is take advantage of one of the gas laws. This is Charles' law. And so as the water is heated, there's just a tiny bit of water in here. It forces out some of the air, and you also have water vapor building up. I'm going to put on a balloon on here so you can see. Let me let a little more water vapor generate. Okay, looks pretty good. So let me put this balloon on here very carefully, not burn myself. And you see what happens as the water vapor expands. It's causing the balloon to expand also. Not surprising. Let me stop this before it gets too big. And what I'm going to do is cool it rapidly. And think about, I'll explain what's going to happen in a second, but I'll just show you first. So let's take this out and cool it rapidly.
Hold it up, I can't see.
I'll take it out in a second.
Okay.
So I don't know if you can see that, but I'm going to take this out. And so here you have a balloon inside a large Erlenmeyer flask. And so what's happened is as you force some, so as the water boils, you force out some of the air particles, so you have a little bit less air in there. And then also as you cool it really rapidly, what's going to happen is that some of that water vapor condenses, and also the gas that's in there, it has a much lower energy level, and so what happens is the pressure inside here drops very dramatically, especially when you throw it into a cold water bath. And the outside is still at atmospheric pressure, so what happens is you force this balloon to open up inside a jar.
Cool.
Example 2.6. A balloon was filled with air until its volume reached 4 liters at 27 Celsius. What will be its volume when we put it in a fridge at 0 Celsius? Pressure is the same for both temperatures. And the volume V1 is given. V1 is given. T1 is given, T2 also given, but we have to convert the temperatures from Celsius to Kelvin. T1 Kelvin is equal to 27 plus 273 is equal to 300 Kelvin. T2 is equal to 0 Celsius plus 273 is equal to 273 Kelvin. And we can write the relationship here. V1 over T1 is equal to V2 over T2. From here we need to calculate the V2. V2 is equal to V1 times T2 over T1. V1 is 4 liters times T2 is equal to 273 Kelvin over T1 is equal to 300 Kelvin. Kelvins are simplify each other. The answer is 3.64 liter. Exercise 2.5. 1 liter of carbon dioxide gas is found in a balloon at 27 Celsius. What happens when we put the balloon in a pool at -3 Celsius? Firstly, we have to convert the temperatures from Celsius to Kelvin. T1, T2, and the V1 also given. We have to calculate the V2. T1 Kelvin is equal to 27 plus 273 is equal to 300 Kelvin, and T2 minus 3 plus 273 is equal to 270 Kelvin. And we can write the relationship again. V1 over T1 is equal to V2 over T2. We are calculating V2 again. V2 is equal to V1 times T2 over T1. We know what is V1. It is 1 liter times T2 is equal to 270 Kelvin. T1 is 300 Kelvin. Kelvins are simplify each other, and V2 is equal to 0.9 liter.